So all of you have your class example 3 in front of you. So it says that determine the sample statistics and compare the three distributions of annual rainfall for the records shown in the table below. Now, if you look at the three area, the first one is in Alabama, like which is kind of southeast, right? The next one is Los Angeles, which is on the west side of this country. And another one is Richmond, Virginia, which is pretty close to us, but at the same time, it's kind of northeast of the country, right? Now we have three different locations, which is far away from each other, which is good. So we can compare the results. So that's what we will do. Now we have, do you have all the data? I think I removed all the data from here. Okay, so this is the data set we have, right? All of you have that? Okay, now I gave you a summary table here. We will find the arithmetic mean, we will find the standard deviation, we will find the coefficient of skewness. Okay, so basically we have three tasks, and for those we have to do some other work also. And once we have all of those, we will try to comment, or we will write down some observations we are having from this data set. Okay, so the very first thing is the arithmetic mean. What is the what does that arithmetic mean? We will add everything and divide by the number of observations, right? That's the arithmetic mean. Now, then the first thing, you need the number of observations, right? So how many data, like how many years of data you have? 23. So how can you do that? The first thing, if you have a small amount of data, you can just select this way. I'm seeing the count is 23, okay? Or there is an inbuilt function in Excel. You can just type equal count and select the cell. It will count the total number, okay? So I found the total number here is 23. You got the number also, all of you? Okay, so that is the first thing. All of you got 23. Okay, now can you calculate the arithmetic mean for these three states? How you will do that? You will find the summation of that and divide by n, or there is another function called average, like you will just type equal sign average and then you select the cell. It will give you the average of the selected cell. Okay, now what we will do, since we have an ample amount of time, kind of 35 minutes, we will make sure all of you are doing, like all of you are comfortable with Excel and doing things I can help. Okay, but first find out the average or arithmetic mean for this one. Increasing a little bit the font. From the back, you can read all the numbers. Okay. Aiden, you can read, Aiden, from here. I mean, you're too close. Okay, I'm giving you the numbers, and you can check if you got the same number or not. You got that number, all of you? And make sure you hit Control S time to time so that your work will be saved. So all of you have that, this number on your Excel copy? Okay, you need to say yes or no. Okay, good. Now, the next step is we will find out the standard deviation, right? So the equation, if I write down that, okay, let's find this. So the equation A square is 1 over n minus 1 summation of xi minus x bar square n I equals to 1, right? So that means we need to find out the individual difference from the mean for every single data and then square it and summation, find the summation of that, right? Now, if you look at your Excel copy, I gave you some blank spaces just for that x1, x minus x bar square. Okay, so can you find the, like, can you fill out these 3 columns with data? So I'm giving you the first one. You can check if you got that one, that number. Did you get that number? So what you will do, you will subtract the mean from 48. I'm showing you the equation here. So you will subtract the mean of that one, 57, from that 48, which is x minus x bar, and then you square that. Okay. And let me know if you don't get that number. All of you got the first row? Okay. If you can get the first row, I'm sure you will be able to find all of the rows here. So that is the number. And once you get all of these, you can find the summation. This one. Let's check if you got that summation or not. And if you didn't get that, we know if I can tell. Most probably you didn't fix the mean. Go to the second one, go to the first one, very first one. This one. So we see M5, you just say M5, you didn't fix that. So once you go down, it is taking different values. So you know how to fix one single value. Is the dollar sign? Yeah, and which one the 5 also. Now copy that one again. Yeah, now copy that. Now we should get yeah, the same thing. If you got the same number, you should actually get the exact same number because you're using the Excel. Once you get all the values, find out the what the number. So once you got that number, now you have the square term. N is 23, so n minus 1 is what? 22. Can you calculate the square? Like this one? Is a square. And once you get this a square, you can make a square root and get the standard deviation. But before that, Please make sure all of you have these numbers, these three numbers. All of you have the three numbers on your copy? All of you? Okay. Okay. When you have something positive, you have to be very loud. Yes, yes, we have these numbers. Okay, now, once I calculated the a square and then I square root that, I got these number. Can you check if you got the same number or not? Oh, that is another word that was I was just about to discuss that. Your Excel can give you the standard deviation, but I discourage that. I discourage to use that because during your test you are not allowed to use an Excel. So I will give you the equation. You are allowed to bring the random equation. So it's better if you use the equation, but at the same time you can check in the standard deviation equation like from Excel. Oh. Yes. I will say you can just make sure your calculation is correct, but don't use that. Because if you do something wrong, and if you just use your calculator, there's no way I can use a partial point. But if you show the word, like even if it's wrong, but lateral, so I suggest you use the equation, but just to make sure your calculation is correct. Square, like square root standard deviation, but once you get the square, just get the square root of that, that will be the Oh, okay. Yes, that will be it. Yeah. Okay. So, yes. So for this one, what we will do, what is the equation for standard deviation you have? A square. That is the square. So you will make the square root of the equation. Okay? Make sure you use the parentheses properly. You have some questions?
Yeah,
on that? For this one,
Yeah.
that one is actually for the standard coefficient of skewness. So at this point, find out the a square. This one. Okay? So you can calculate here a square. That's
So we're just taking the square root of that.
not the square root of that number. Actually, find the square. The square is what? 1 over n minus 1, and then the summation. So calculate the a square here. Okay? And then here, just take the square root. Okay? Okay, it seems some of you are a little bit confused. So what we will do, this 5301 is the summation for Aniston Alabama, right? 5301. So what we will do here, one over 23 minus 1, 5, 3. What is that number? 01. Now what is that number? That is the square. Can anyone give me that number? Five three zero 1.09, something like that. Okay, what is that number? Do that on Excel. Okay, something like that. Now, if you square root that a square, so you will square 241, something like that. And I think you will get that 15.51 or 52. Okay. Now, those are done with the standard deviation. Can you start working on the last one? Coefficient of variation. If you are not done with this one, I can help you if you have any problem. You're done? So how many of you are done with the standard deviation? 1, 2, 3, 4, okay, 5. Okay, we will wait a few more minutes maybe. Now, those who are done with the standard deviation, try to work on the coefficient of skewness. Okay. Oh, one more thing. Find out the coefficient of variation. What is that? Coefficient of variation. CV equals to S over X bar, right? Calculate that one. Martha, you got the number? Anthony, you got all the numbers? Yeah, so this one is actually the ratio between standard deviation over mean. So basically you will divide column 6, sorry, row 6 by row 5. Okay, like 15.52 over 57.22. So do we have that, all of us? Okay, we'll wait a few more minutes.
What's the X represent?
X bar, the mean, the arithmetic mean. Yeah, yeah. Fifteen 15.52 divided by 57. Did you get that? Okay, class. So what is the last thing we need to find for this table? Coefficient of skewness, right? So coefficient of skewness, if I write down the equation, this one is the coefficient of skewness is A over S cube, right? Now we already have S, so we can find S cube easily. So what is the only thing we need to find? A, right? Now if you look at your copy, the equation for A is, if I write down the A, this one is n minus 1, n minus 2, summation of x minus x bar cube, right? Now, if you look at your Excel copy, I again left some spaces for x minus x bar cube. Can you do that again, just like you did for the square? Okay, to do that, I'm giving you the values just to make sure you can match. Do that and find out the summation and make sure those are the numbers. This time you can get negative because the power is cube. So if the difference is negative, if you cube that, it will be again negative number, right? check the first two rows first, just to make sure you did the calculation correct. If you are not getting those numbers,
I mean, I got the first round when I do.
I think you need to again fix that.
I have the dollar sign.
Still, it's not working. Okay. Okay, those you have the same number as I have, you can calculate the A. The second row is not working. On that. So 9 minus n65. Where is n65? That should be n5, I guess. That one should work now. Okay, class, do we have the summation of this cube term? Last row, all of you? Anthony Ampar, all of you have that? Okay. So, is this the summation number you have? Can you check that quickly? Okay, good. Now, Micah, do you have the number? The same number as I have here for the cube? Okay. So, once we have the cube term, now can you calculate the A, all of you? Okay, what number you got for A? Is that 6320.97 and negative 34.58? All of you? Okay, and once you have A, I just wrote the equation for coefficient of variation, which is A over S cube. Can you again calculate these three? A over S cube, A over S cube. Okay, there is one confused. This arrow meant nothing. Did you get that 1.69, 0.17, and 0.17? Okay.
Wait, can you give like,
A. This is the equation for A. And if I click the equation here, okay. Here. So what I did, I used n over n minus 1, n minus 2, which was 23 over 22, 21, and multiplied with this whole thing. Did you get that number or you got something different?
yeah, no, I got something.
Okay, I will come to you. Just give me 2 minutes so that I can make some comments and then I will come to you to fix that, okay? Okay, now, how many of you got this table, like the complete table? Okay, okay. Even if you don't have all the numbers, let's make the observations and then we work on like whatever problem you have, okay? Now, coefficient of variation. Can you tell me which area has the most variation of rainfall, annual rainfall? At first, tell me which area has the lowest annual rainfall. The Los Angeles, which is kind of like we understand that is a dry area. But if you look at the coefficient of variation, which one has the most variation? Which is kind of strange, right? They have the lowest annual rainfall, but if you think about the variation, like maybe one day they got a huge number of rainfall, next day, next few weeks, no rain, nothing. So that's what we're seeing from here. Now, Which one has the most skewed data? Which area? Alabama, California, or Richmond? The Alabama has the most skewness, maybe because Alabama as a like state, they get enough rainfall. Obviously, you can see that 57.22. So maybe they got like 57, around 57 number a lot. That's why they have a huge skewness. But for the other two, they are kind of same. One is like they are just two different directions, right? Now, for your test or for your homework, if I ask you to make this type of comments, can you do that from the observations? Okay, sounds good. So what I'm doing, I will just stop recording this problem, but I will be here to answer your question. Okay.